Okay, so in this video, we're going to be talking about how we can prove that two functions are in fact going to be inverse of each other. And we're going to do this by using compositions, okay? Now I have a video on compositions, so if you don't know how to take the composition of functions, go ahead and check that video. I will link it below. But assuming you know how to take compositions, let's go ahead and start this video. So you can see that I have two functions here. I have g of x and I have f of x. And the goal is to prove that these are going to be inverse of each other. Now, they may not be inverse, but how do we know that? How can we prove that out? Well, we're going to do that by taking the composition, all right? So it's really simple. You're going to do f of g of x, okay? And then you're going to do g of f of x, okay? If these are both equal to x, so if you do f of g of x and you get x, and you do g of f of x and you get x, that means that yes, these two functions are going to be inverse, okay? But they both have to be equal to x. So we're going to have to take the composition 2 times here. So let's go ahead and get rid of this here. And we're going to do f of g of x first, okay? So if I do f of g of x first, that means I'm taking this g of x right here and I'm plugging it in wherever I see an x on my f of x, okay? So I'm going to go ahead and write it out, f of g of x, okay? And then right below, I'm going to go ahead and start plugging it in. So my f of x is -3 plus x to the 5th power. So I'm going to write -3 plus, and then in parentheses, I'm going to plug in my g of x because I have an x here. So in parentheses, I have the 5th root of x plus 3, okay? And then closing it all to the 5th power. Now I have an index of 5 here on my radical, okay? So that means since I have an exponent of 5 here, these are essentially going to cancel out. And as a result, I'm just going to be left with x plus 3. So this will cancel, this will cancel. Now I'm left with -3 plus x and then plus 3. Well, -3 and 3, they cancel out and I'm left with x, okay? So this one works out. Now we have to try the other variation, which is going to be g of f of x. So I'm going to go ahead and write here g of f of x. So I'm taking my f of x function and I'm plugging it into x wherever I see that on g of x. Okay, so going ahead and writing this out, my g of x is the 5th root of x plus 3. So I have the 5th root of x. Now, again, wherever I see an x, I have to plug in my f of x, which is -3 plus x to the 5th power. So I'm going to write -3 plus x to the 5th power. And then I'm left with this +3 right here. Okay, so I have to write plus 3. Now, -3 and +3, those are going to cancel out. So I'm left with the 5th root of x to the 5th power. And these will cancel out. Since I have a 5th root here and I have x to the 5th power, the exponent will essentially cancel out as well as the 5th root. So this is gone and this is gone, and I'm just left with x here, okay? And so this checks out, okay? These are in fact going to be inverse functions, okay? All right, let's try another example. So here's my next example. I'm going to go ahead and write out the 2 compositions that I have to take. I'm going to do h of f of n, okay? And then I have to do f of h of n, okay? So doing this one first, I have to look at h of n, and wherever I see an n, I have to plug in f of n, which is 2n minus 4 divided by 5. So going ahead and doing that, I have 4, and now here's my n. I have to plug in this entire function here, f of n. So that's going to be 2n minus 4 all over 5. Close it. And again, I'm going to be dividing by 5 here. You can see that right here. So dividing by 5. Okay. So I'm going to go ahead and distribute this 4 right here. When I do that, I get 8n. And then minus 16 all over 5, okay? And then divided by 5. So think about keep, change, flip, what you have to do here. You have to do 8n minus 16 over 5, so this part here, divided by 5. So if you think about keep, change, flip, it's going to look the following way. You're going to have 8n minus 16 all over 5. Again, it's division. We're going to switch it to multiplication. And then we're going to flip our next fraction, which is really 5 over 1. It becomes 1 over 5. So 1 over 5. All right. And so you can see here, right, it doesn't look like we're going to end up with just an isolated variable here. Okay. In this case here, n. So as a result, I can go ahead and stop this problem right now because they both have to check out. And if this one's not checking out, it doesn't even matter what the other one does. So this problem right here, no, these are not going to be inverse functions, okay? And again, just to show you what I'm left with, I'll have 8n minus 16 all over 25. So again, you can see here that this n is not going to become isolated, right? I'm left with this whole part here. These are not going to be inverse functions as a result, okay? Let's go ahead and try one more example. So here's our last example. Again, I'm going to write out the compositions that we have to take. We have to do f of g of x. And then we have to do g of f of x. Okay? So let's go ahead and do this one first. I'm going to take my g of x and I'm going to plug it into x on my f of x function. Okay? So I'm going to have 4 over negative, and then in parentheses, I'm going to plug in my x value, which in this case here is going to be negative 4 over x plus 1. So putting it in parentheses, I have negative 4 over x, and then plus 1, okay? And then I have plus 1 again. So this one looks pretty messy, but we'll work through it. I have to go ahead and distribute this negative right here. So if I distribute that negative inside, I end up with 4, and then here I end up with positive 4 over x, so positive 4 over x, and then negative 1, and then plus 1. Well, negative 1, positive 1, they cancel out, so I'm left with 4 over x. And again, that's really 4 over 1 divided by 4 over x. Think about keep, change, flip. It now becomes 4 over 1 multiplied by x over 4. Again, keep, change, flip. Now the 4's will cancel out. I'm left with x. I have x over 1. So this one checks out. Okay? Now we just have to prove it out on the other composition. So this one here, I have to do g of f of x. So I'm going to take my f of x function, and then I'm going to look at my g of x function, and wherever I see an x, in this case here, right here, I have to plug in that f of x function, all right? And before I start writing it out, I'm going to take this negative and I'm going to put it on the numerator, okay? You can put it on the denominator if you want. You can even leave it out in front like that, but I like to assign it to the numerator rather than leave it out in front, okay? So I'm going to say here, negative 4. Now here's my x. I have to plug in my entire f of x function. So I'm going to put 4 divided by negative x plus 1. And then finally, I have this plus 1 still here, right? So plus 1. So what you want to do in this problem is take care of this part here first. It will probably simplify down, and then we can go ahead and go from there. So again, think about keep, change, flip. What's going to happen here? Well, this is really negative 4 over 1 divided by 4 over negative x plus 1, okay? So what do we need to do here? Well, we want to do keep, change, flip. I'm going to do negative 4 over 1, change it to multiplication, and I'm going to flip this last fraction here. It's going to become negative x plus 1 all over 4. Okay? So from here, you can see that the 4's are going to cancel out. Okay? And then these two negatives are going to make a positive, right? But be careful here. This negative that you have right here, you have to make sure that you distribute to both the negative x and the positive 1. So again, this negative has to go both here and here. Okay, not just to the negative x. It has to go to both the negative x and the positive 1. So if I do a negative times a negative x, that gives me positive x. And then a negative times a positive 1, that gives me a negative 1. And again, technically this is all over 1, but I don't have to write that, right? It's just x minus 1. And then remember, I still have this plus 1 right here. So then I'm going to write plus 1, And then the negative one and the positive one, they cancel out. And there you go, I get just x. So this one checks out as well, meaning, yes, both of these functions are going to be inverse of each other, okay? So that is how you can determine if two functions are going to be inverse of each other. You can do it by using compositions, okay? It's pretty straightforward. Just make sure you take your time and make sure that you're setting up two different compositions because, again, you have to make sure that it checks out two different times, okay? If you reduce down to a single variable, then you are good. But if you're unable to do that, that means they are not going to be inverse functions, okay? So that is it. I hope that you gained something from the video. I hope that you learned something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel. That way you get more math videos in the future, and I'll see you in the next one.